Welcome back. In our last video, I showed you a basic example of an ionic bond between lithium and fluorine. The goal of this video is to show you a slightly more complicated example of an ionic bond. Let's start by reviewing the bond between lithium and fluorine. Lithium has one valence electron. Fluorine needs one valence electron. So therefore lithium's one electron is donated to the fluorine atom. As a result, lithium loses one electron and fluorine gains one electron. And it's the perfect match. Examples don't always work out quite that nicely. Let's look at a slightly more complicated example. Look at question 13 on your worksheet. Question 13, we have beryllium combining with fluorine to make beryllium fluoride. You'll notice in my drawing that I've drawn one beryllium atom but two fluorine atoms. Let's talk about why that is. Beryllium is element 4 in the periodic table. The best way for it to achieve stability, in other words, look like a noble gas, is to lose two electrons so that it looks like helium. And so that's what it wants to do. Fluorine, on the other hand, is element 7. It has 7 valence electrons. The best way for it to achieve stability and look like a noble gas is to gain one electron so that it looks like neon. So back to our diagrams. Each fluorine atom only wants one electron. Each beryllium atom wants to give up 2 electrons. So the only way everyone can be happy is for beryllium to give up 1 electron to each of 2 different fluorine atoms. And therefore our ratio for the compound then is 1 beryllium atom for every 2 fluorine atoms. And then in terms of filling out the rest of your worksheet, we would write beryllium loses 2 electrons. Each fluorine atom gains 1 electron. So each beryllium atom, in this case there's only 1, becomes a +2 charge. And so each one of our fluorine atoms becomes a -1 charge. Another way to look at this is that the overall charge for the compound is 0. You have 1 +2 charge and 2 -1 charges. And so that gives you an overall charge of 0. I'll see you next time.